Welcome back to the Epic Web3 podcast. My name is Alex. I'm co-founder and CEO of Epic Web3. We make professional events for Web3 builders. Our next events will be in Brussels in July. And my guest today is Martin Derka, co-founder and technical lead at Zircuit. Zircuit is a modular ZK rollup, and Martin is the brilliant mind behind it. He holds a PhD in computer science and has co-authored over 40 academic publications in computer science, software engineering, mathematics. And Martin also has many years of experience developing smart contracts, platforms for building Ethereum, specializing in DeFi security and economic manipulations. So I'm excited to talk with Martin today about his journey, how he decided to start Zircuit, his vision for why Zircuit should become a leading layer 2 on Ethereum, innovations in the ZK space, Ethereum scaling, and much, much more. So I suggest we dive in. Martin, welcome to our pod.
Beautiful. Thank you, Alex. Very happy to be here.
Yeah. So first of all, could you start with how you came to the point where you started Circuit? So I understand that you began as a software and research engineer at QuantStamp, which is a security audit company, right? And before starting Circuit, you spent a couple of years making research on different L2s. So could you tell us about it?
Yes, absolutely. So, at QuantStamp, my position was the head of new initiatives, which essentially means that I was helping the company search for new products that, had some synergy with what QuantStamp does. And while I was doing that, at one point, one other co-founder on the Zircuit team, his name is Krishna. He was the managing director at QuantStamp. He came in and he said, you know what? Like, you guys are actually looking into rollups, right? So, how hard would it be for us to actually build one? And that was a very intriguing question for me because, myself, as well as a few other engineers who are currently doing the research with me, we were very interested in rollups. We were very interested in sequencing protocols. We were very interested in the differences between the optimistic and the zero knowledge technology and the security implications of those. And we had essentially a lot of expertise and then very strong personnel with a good skill set. So I was wondering, maybe he has a point. And so this is sort of how we, transitioned from being security researchers to being rollup developers. And that was the inception of Zircuit. So that sort of really ties well into what Zircuit brings to table. So you mentioned that Zircuit is a module rollup, right? But I would like to say that perhaps the major innovation that Zircuit brings to the world is its focus on security. Because coming from our origins in the security space of Web3, we kind of thought, hey, blockchains and rollups, they do a lot of stuff, but majority of what they do is essentially for the protocol itself, right? They provide a lot of security guarantees to the protocol, but those are provided so that the consensus can sort of work, and so that the platform can operate in the first place. But they in the end do not do much for the user. When a transaction shows up somewhere in the mempool, what the blockchain does is that it validates that the transaction is properly signed and it can be included in the next block. But whenever the block proposer, or whatever the block forming entity is, finds a suitable block space for this transaction, without any further scrutiny, that transaction is going to be included and is going to modify the state of the chain. And if that transaction has the effect of draining somebody's money, or exploiting your favoring protocol on that blockchain, it's just going to happen. And so, having this security background, we actually thought one can probably do quite better. We can take a look at what transactions really do, what effects they have. And before finding that very first suitable block where the transaction can be included, we can be asking questions. Is this going to be good for the chain? Is it going to be good for the users? Or is it going to harm somebody? And so what Zircuit does is that it brings its special sequencing protocol. We call this concept sequencer level security. It vets all the transactions, and the ones that do signify some kind of an exploit or hack, it doesn't include in the next available blocks, and it puts them in quarantine instead. So this is the novelty that Zircuit brings to the table. But otherwise, as you mentioned, Zircuit is a novel modular zero knowledge rollup. For detection of hacks, we use some AI and machine learning models, and primarily we are here to scale Ethereum. So you could expect from this rollup network everything that you would expect from every single other rollup out there.
Yeah. So you made a lot of researches, understood these technologies really well, and saw the opportunity in the market, right? That how it
Absolutely.
worked. So what was the opportunity which you saw? I mean, there are already a bunch of different rollups. They are different. I mean, each of them is kind of unique. So did you see the big problem in security in general, or so why did you think you can put something new to the table?
Right. So, the very first ask that we should make is, why did we decide to build a zero knowledge rollup, right? Because when we look at rollups, we have two types of rollups. We have optimistic rollups and we have zero knowledge rollups. So, we always considered the zero knowledge technology superior to the optimistic technology. And this conviction came to us from the point of view of what's going to happen when things go wrong. This is kind of like this weird question that every single security researcher always has in their mind. How can I make things go wrong, and what will be the implications if something goes wrong, right? So when you look at rollups in general and specifically at the optimistic rollups, the one thing that can go wrong is that somebody submits a fraudulent state on chain, right? And then the optimistic rollups, they have this waiting period where anybody can submit a challenge to this potentially fraudulent state. Now, this waiting period is fairly long. It's 1 week, right? So that everybody has enough and sufficient opportunity to actually do so. So it's entirely possible for you to be waiting for 5 days and assuming that if you are a kind of user who is not watching, you are relying on everybody else doing this job for you, right? So you are sort of safely assuming that everybody else is watching, and somebody would have caught this fraudulent state already, but you have that waiting period of 7 days. So it's totally possible that 5 days into your life, somebody's going to show up and say, hey, you know what, we actually had a problem in here. The problem has happened 5 days ago, and therefore we have to roll back the chain 5 days. And that is something that did not happen yet, right? Any kind of challenges that we might have would be in the first place sort of fabricated, and therefore also kind of caught very soon after they happened. So this issue where we would be rolling back a significant amount of history didn't happen yet, but we were thinking what would happen if it did, and the conclusion was, we actually do not know. It's nearly unimaginable of what would happen if you rolled back a history of a chain by 5 days. You would, have some exits, you would have some double spend that, would be a severe situation. So from this standpoint, we actually saw the first opportunity by building a zero knowledge rollup. We didn't want an optimistic rollup. And then the second opportunity, as I've already mentioned, that was the security background. So we did ask ourselves, could networks and could rollups do better for the users? Because the status quo that if the rollup is implemented without any bugs and is capable of protecting its own protocol, we didn't think that this was enough. We saw a lot of space for giving a little bit more reassurances to the users and doing a little bit more for them, right? So that was the second kind of hole in the market that we didn't think that anybody else was covering well, or anybody else was covering in the first place.
Gotcha. I recently had a pod with guys from Movement Labs,
Mhm.
and they also their big bet is also on security, because the Move language, as I understood, is all about security. What do you think? What do you think of their approach, and what do you think of how Move deals with the security, and what is the main difference between how you tackle it?
Right. So I think that these approaches are, in great extent, very similar. Obviously, there are some, deeply technical differences between the runtime that Move follows and the runtime that we are, using on Ethereum, right? So there would be differences, but they are so nuanced. I think that the approaches are, to a great extent, similar. So you can
Yeah.
proceed similarly.
Okay. Okay. So, how do you see the landscape in general? How many different L2s are needed in the industry in general? I mean, somebody tells that there will be, I don't know, thousands of different rollups. Every app will have its own app chain, right? But maybe it will be a little bit more consolidated. So, what's your vision here?
Right. So, this is a very philosophical question, honestly. How many roll-ups does the industry really need, right? So, what I say is that many trends in this space, and not only this space, sort of follow a sine wave. One day we are closer to the landscape that is very fragmented, and everybody wants to have their own roll-up. Then people sort of look at that and say, hang on, this is actually maybe not the best thing for us because we have other issues that, come from fragmenting the liquidity, for example, and so on, right? Which both gives us maybe some opportunities to develop new products. Liquid restaking is currently, quite big, right? And then in the end, in some way, it tackles the fact that you have assets locked on one network, but you sort of would like to be reusing these assets somewhere else as well for other purposes, and battle this problem of fragmentation, right? But in the end, it is some form of a sine wave. Sometimes we like being very fragmented, some and have everything, multiple times. Sometimes we do not like it, and the general opinion of the community, varies, right, and oscillates. And therefore, the question of how many rollups do we really need and why, I would say as many as the community currently desires. This is a very open space, and then we sort of love Web3 for its openness, right? If I right now can come and develop a network because I have a better idea, or essentially I can attract the interest of the users better than everybody else, then clearly there is space in the universe for my network to exist. If I can retain this interest, then my network will exist. The moment when nobody cares, when all transactions sort of fizzle out, the traction disappears, then nobody cares about my network, and probably this network will not survive much longer. So it is the interest and the traction that the networks are capable to receive, and that is going to dictate the number. And that one day it's going to be larger, one day it's not going to be larger, and it's going to be smaller. The one thing that I would sort of like to challenge is that opinion that every single product and every single, let's say, DeFi protocol or something like that will have its own rollup, right? There is, let's say, some baseline cost that it takes to operate a rollup, right? Imagine that you are right now starting a new network. Well, what you need is some kind of a community of node operators that will be operating those nodes. Every single node has some minimum hardware requirements. Those can be, fairly cheap or more expensive depending on what exactly your network is about and how exactly it achieves the consensus and what exact requirement it has. But it unfortunately is not ever free, right? With that comes a whole set of other questions. How are you going to ensure that these nodes are kept up to date, right? Let's say, from the very simple call out of security vulnerabilities are present in the libraries that you are using, to the space have shifted and you have to update your stack somehow, maybe to implement blob storage or whatever novelty just came on Ethereum L1, or your favorite new data availability solution. So that also doesn't come for cheap, right, or for free. So it's a significant commitment, and from this standpoint, like we're essentially saying, if every single protocol was to also operate the network that they are building on, we are saying, hey, stop using the platforms that are available to you and start inventing new platforms for yourself so that you can operate. And, just looking back into Web 2, right, it's not the case that every single website that we would like to create also builds their own data center and server farm and content delivery network and so on. It's just unnecessary, and that field has figured it out a long time ago, and I think that we have figured it out as well. So I do not subscribe to the idea that every single protocol will have their own network, but I also do not subscribe to the idea that the number of rollups that we need is going to be small, and should be small in the first place. I think that healthy competition and healthy innovation is something that this space needs quite a lot and is very open to. So I think that we'll be following these patterns.
So what's your bet? I don't know, 100, 1000, 10. let's
Give
just
me a date, right? Because tomorrow is going to be different than a year from now. So give me a date.
Okay, let's take, I don't know, let's take 3 years from now. I don't know, maybe 5 years, maybe 5 years is too much for crypto, I understand.
Well, I'm wondering if 3 years is too much. This is like a forever in the technology.
Yeah, exactly.
So, okay,
Exactly.
3 years from now, okay, I will say that 3 years from now, we will have at least 50 rollups that will have at least one application on it.
Okay, with one application. I feel it's rather conservative. I think there will be more, but yeah, let's see. It's interesting. It's interesting
Well,
to see.
I also say, that we'll have one application on it, right? Because you can start a rollup network with nothing on it. It can just be platform on its own. Nobody can be using it, right? So I think that the one application modifier is quite important. But yeah, maybe I'm wrong. Maybe it's
how many users? So it's also important. It's also an important question. One application, maybe with. Yeah. Okay. Let's see. So and how I know it's totally different. Like to build a service company and to make services for other products, and to make your own product. From your experience, so you are now building your own rollup. You made a lot of research audits, different things before for others. What is the main difference for you?
What is the main difference? So first of all, we have a lot of advantages compared to the teams that didn't start the way we started. Right. The main advantage is there that we have kind of seen all. Well, I probably shouldn't say all, but quite a few mistakes that other developers made in the past, right? So I guess the major difference now is not just pointing at these mistakes, but actually making sure that these mistakes will not happen for us, right? So that we have actually applied the learnings that we acquired in the past. Obviously, it's also a very different experience, because before, when providing security audits for projects and smart contracts and similar things, we were always on the provider end. Now we are on the receiving end, and the stakes are a little bit different, right? Or let's say the interests are a little bit different. This is actually why we have this separation between the auditors and the builders in the space in the first place, because many builders will actually tell you, yes, I am capable of doing the security audit myself, because I have to know the nitty-gritty of Ethereum because I'm developing on it. But you essentially have to be carrying completely different mindset. When you are a developer, you're trying to build things, right? Sometimes you cut corners. Sometimes it can be with very good intentions, because you actually, I don't know, needed a mock of some service running so that you can develop against it and test against it and integrate against it and with it. And sometimes, that gets left behind, but in the end you're trying to make things happen, you are trying to build stuff that did not exist before. Now when you are a security auditor, your mindset is completely different. Somebody gives you a code and they make some claims about this code. This is secure, this fulfills certain features, this has some functionality, and your task is exactly the opposite. You want to rip it apart and break it, right? You essentially are assuming that everything in here is wrong, and you want to prove this other person that everything is wrong. And only under such circumstances you are actually doing your job properly as a security auditor or researcher. And so this is the main difference in the mindset. And yeah, I think that that's the best way of describing it. So it's completely different. It is completely different, but you can very clearly benefit from having the previous experience, right? We also, when we work with our auditors, we know how to prepare the materials for them, for example, so that they have a little bit easier job conducting these security reviews and audits, right? We know what happens on the other side, therefore we are able to be a little bit more efficient. We also very well understand what they are saying when they, bring some findings to us and say, hey, this is wrong. We, very well understand that, they are coming from a position of, I was trying to break it. I was actually thinking how I could be harmed if I was a user of this platform. And here is an attack vector. So we understand that this is something that immediately needs to be addressed and shouldn't be swept under the rug, and so on, right? So it is a completely different experience, but yeah, we are able to benefit from our kind of expertise in both the areas.
Okay. Okay. Let's talk about the Zircuit's tech a little bit more. So
Sure.
I know that it has kind of a hybrid architecture, right? So it is a ZK EVM built on the OP stack, and as far as I understand, it is not something usually used in the blockchains. So can you tell about this? Why did you choose this stack?
Right, absolutely. So, think about yourself trying to build a rollup right now, right? You will need to create a lot of services that will form this rollup. You will have to have something that takes care of sequencing of the transactions. Then, once the sequence of the transactions has been formed, you have to somehow clump them together to some kind of a batch and record them on the data availability layer, right? That data availability layer, at least in the protocol that is defined by Optimism Bedrock, will then be backwards read by your sequencer, and the state will be backwards rederived from what was actually recorded on the data availability layer. And that needs to happen so that there is no discrepancy between the data that you have published for your users and the state that you are currently maintaining, right? Once you have that, you need to take that state and decide that at some point you are going to roll it up, right? So you need something on L1, some smart contracts that you will be recording the state into. Those smart contracts, they will be fulfilling either the verification purpose in the zero knowledge setting, or they will be just holding the state, giving everybody the chance to challenge it if you are in the optimistic setting, right? But they will be for fulfilling some logic. On top of that, so that your transactions can happen in the first place on L2, you need to have a way of giving people the native assets, the ether that they will be using on L2. And the way how you typically give people these assets is by them providing L1 assets, locking them in some kind of a bridge, and you then mint your L2 ETH against those assets that are locked in the bridge. So you need this functionality of L1 being able to lock ether, and then that off-chain component watching what happened on L1 and issuing that ether on L2. There is a lot of stuff. But all this stuff is, let's say, quite generic. I was able to explain to you what you need to build in here, and not even once I needed to use the word Zircuit or we do in Zircuit, because this is generic to the functionality of rollups, right? And These generic features, this is actually something that is implemented inside of the OP stack. The OP stack at this moment should be perceived as a framework for developing rollups. It's developed by Optimism Labs, and therefore, it is catered towards optimistic rollups. So we said, fine, it gives us a lot of stuff, very good starting point, but not all this stuff is actually compatible with the intention of developing a zero knowledge rollup, right? So as our starting point, we took this framework and essentially we ripped out all the optimistic parts that were out of it in there because we needed to replace those optimistic parts with the zero knowledge components. Now, when you start looking for how you could develop your zero knowledge EVM, you will also find some very good starting points, right? For example, the PSC team, they have published a zero knowledge EVM. Now, what you will run into troubles with those ZK EVMs is that some of them are, very much catered towards compatibility with Ethereum. There is this like hierarchy of equivalence that Vitalik at some point posted, right? And the biggest, let's say, most compatible or most equivalent type says this ZK EVM should be strictly able to verify the history of the entire Ethereum chain because it is fully equivalent, right? Well, guess what? These actually cannot really work with rollups in the first place because, for example, as I described, you have this very initial problem of how do you credit accounts with Ether when this Ether is bridged from L1? You, in the true nature of EVM, you cannot just come and credit an account with Ether out of thin air. That's not an EVM equivalent operation, right? So then suddenly when you are taking this rollup architecture and you need to create the circuits that will support this rollup, you will also need to make some modifications. So in our work, what we have done is the second step as well. We have made modifications to the circuits so that they can actually initially function with the framework, the adjusted framework that we have obtained using the OP stack. And then we married those together. It's much more effort than it sounds like when I just describe it this way. But we have done that. Now, this is not a moment when you can stop. If you want to have a fully functioning rollup, you will suddenly have to start being concerned with other topics as well, right? So be it those special features that I have described, such as the sequential level security, that has to be somehow incorporated in both these stacks as well. But you will also have some, fundamental topics that revolve around the operations, right? So you have a ZK EVM, you will have to be, concerned with the proving performance that your ZK EVM requires. You will have to be concerned with operating that infrastructure that it requires so that you can actually operate it in the first place and make it available to the users. So that, then requires some additional modifications. They might, depending on what exactly you are, sort of required to do, they will be happening either on the side of the sequencing and the OP stack or inside of your circuit or both. So this is kind of the holistic approach and how we arrived to the hybrid approach that we are currently following. Overall, I think that it's serving us pretty well. Many things I think are easier. They are definitely not for free, but I think that sticking with the well-known architecture and the well-known stacks is very useful. On top of that, we obviously can benefit from the communities that are behind these solutions that keep progressing the development of the OP stack and so on. Because again, it's fairly young technology. It has been around for some time. Optimism is live, right? It's running on it and so on. So it's sort of battle tested. But when you compare it to some old school systems from Web 2, it doesn't have enough years under its belt, right? So obviously the development is still very live and in progress, and we get to benefit from that as well, which is great.
Yeah, thanks for this detailed explanation. And why is it important for you to be full EVM compatible?
It comes back to the tooling. So if you completely, change your let's say that we look at the completely opposite side of the spectrum, right? You can take a look at Starkware and the Cairo ecosystem. You may go as far as completely changing the runtime. But once you do that, you will have a problem with the developers not being able to use the tools that they were used to. So, in this particular instance, they would have to adopt a new programming language. They would, therefore have to adopt a completely new tooling. They would have to adopt new wallets. And we simply didn't want our community to have to do that. We thought that we can again benefit from the experience that everybody has acquired in the past X years of developing on Ethereum, and the closer that we can get into what people are used to, the more mature and secure system in the end we are going to develop, right? Because in the end, the security of the ecosystem that resides on your blockchain, it is very much driven by the maturity of the stacks that the community uses to develop those systems. And we just wanted to get the best out of everything that is out there. Therefore, we are trying to stick to the known stuff.
What are the downsides? What are the challenges of building
Right.
EVM compatible
So,
chain?
depending on what level of compatibility you want to reach, you might have some, let's say, problems or a little bit hard time achieving it while keeping your operating costs down. So, for example, inside of EVM implementation, we use a hash function. It's called Ketchak or SHA-3, and this hash function is notoriously known to not be very ZK friendly. Essentially, if you want your prover or the circuits to generate a zero knowledge proof that hash of some pre-image was obtained in the right way, and this is the correct hash that was used in here, this takes a lot of time. There are some other hash functions that are much more suitable for the use in the zero knowledge setting, such as Poseidon. So it's the concessions of this sort that you will be making. What will I make 100% equivalent? What will I not make 100% equivalent? And have to do some engineering work so that I still retain this final benefit of the users being able to use the tooling that they are used to at the end. So this is kind of the implication and the trade-off.
Okay. Okay. Um, you have this AI enabled phrase on your website, AI enabled sequencer level security. So what does AI do in your case
Yes.
in this thing?
So AI enables us to tell whether a transaction is a suspected exploit or not. So, if I show you a transaction, you can simulate the effect of this transaction and you will see that the transaction has moved $10 million. Is this a hack or is this not a hack? Was it a legit movement of funds or was it not legit movement of funds, right? Those are questions that are not really simple. So that's where we are employing AI. The AI helps us with the detection, and it helps us detect a lot more stuff than just saying, "Hey, this is a hack." It helps us detect, who is the suspected target of this particular exploit. Is it that protocol, or is it that protocol, or is it that protocol? Is it the hack in the first place? What is the suspected damage, right? Because just the fact that I'm moving, $10 million doesn't mean that the whole $10 million is in the end something that I'm going to benefit from as a hacker. So this is how we use AI. If I should tell you a little bit more how that works under the hood. So when you look at a transaction that you have triggered as a user, this transaction is usually very simple. Imagine that you are taking some ERC20 tokens that you are depositing into a protocol, into a DeFi protocol, right? So what you will be doing are two actions. The first one is interacting directly with the ERC20 token, giving the DeFi protocol some capability of withdrawing money from your wallet and depositing it into itself, right? So that's a very straightforward interaction. Your account goes directly into the ERC20 token smart contract. Nothing else happens. Very simple. Then you go to the DeFi protocol and you trigger your second transaction. So you have the DeFi protocol as the first interaction step. It's going to withdraw tokens from your account interacting with the ERC20 smart contract, and it is going to place it into some other smart contract. Again, very straightforward interaction, maybe 3 4, definitely under 10 smart contracts involved in this whole entire flow, right? Why is that? It is because for developers, they actually try to keep these smart contracts as simple as possible. It's for transparency. It's for following good engineering practices. You have spaghetti code, like who the hell is supposed to tell what it in the end does, and how are the smart contract auditors able to tell you that this is actually secure? And in the end, there are gas consequences for the users. The more complicated stuff that happens under the hood, somebody has to pay for it, right? So in nature, all of these, let's say, honest or simple, or the majority of user transactions, they follow this rather simple pattern. When it becomes complicated is when you execute either, or where you take advantage of arbitrage opportunities that you have identified, and when you execute exploits. So that's when stuff becomes very complicated. In both cases, you are interacting with multiple DeFi protocols, right? So the number of smart contracts that is involved goes significantly up. You are usually taking some flash loans that either enable you to execute that hack or enable you to source the capital for closing the arbitrage opportunity. There are multiple entities, and suddenly this like simple pattern where it's like the core protocol that maybe does something on the side, it's just generally broken. So what happens under the hood with these AI models is that they essentially take a look at the trace of the transaction, maybe equip some additional metadata, like the former activity of the smart contract account that triggered the transactions, and they make some assessment on that, and they tell us the information that I have listed before, which is subsequently used by the sequencer level security. The sequencer says, okay, well, I trust this AI, and this AI says that this is a bad transaction for me. Well, let's not place it into the block. Let's put it on hold in here.
Do you already see it this AI model working well, or do you think it still has to be trained a lot and much more data? And
No, it actually works tremendously well. The data set that can be used for training this model, it's extremely rich, right? We have a number of chains that we can look for data for the training purposes, right? Let's say that there are 15 chains with booming ecosystem right now that are EVM equivalent. That's a treasury of data that can be used. So we actually do have the model fully trained. The model is back tested. It achieves tremendous accuracy. Basically, the typical user interaction that I have described, the simple one, the most honest one, despite large movements of assets being possible, it's basically never accused of being somehow exploitative or malicious. So the general user experience on the chain should pretty much remain unchanged. The only entities that have this risk of being accused from doing something falsely are the arbitrage bots that search for very complex arbitrage opportunities, and even in such cases the accuracy of detection, it exceeds 99%. So it's actually very, very good.
sounds cool. Sounds cool. Okay, we talked about the technology a little. You have a unique technology. You're super secure, super good performance, many other things. But is it also important to explain it to the market, right? To the users, to the developers. Because every layer 2 founder I spoke to says their solution is unique, and I'm sure it is. But the user or the developer, for them it might be confusing to choose between different solutions, right? So what is your strategy here? So how to convince the market, how to find your I don't know, ideal users, ideal developers to use your solution?
Right. So, I have to follow the pattern of all the other founders in here and say, please come build on
Yeah.
Zircuit, right? Very obviously, everybody is our ideal audience as far as developers go. So let me change the question. If I was a smart contract developer choosing a chain for my product, what would I, look at in the first place, right?
Yeah.
So, here's the deal. You have to ask what is important for you and your particular users. If you do not care about gas fees in the first place, and you just want to make everything expensive, maybe you don't even need to take a look at rollups, right? Maybe you can actually reside directly on L1, but for majority of protocols and users, the transaction fees, they actually matter, so that sort of brings you to the plethora of sidechain and L2s, right? So then you have to decide whether you want to be present on a sidechain or on L2. Then once you have decided that you would like to be present on L2, then you have to choose that L2 that kind of suits your purposes the best, right? So I've already spoken about the differences between zero knowledge rollups and optimistic rollups. For the users, depending on how exactly the fees are structured on the respective zero knowledge rollup versus optimistic rollup. So the fees on optimistic rollups, they sometimes can be cheaper. The fees that are projected onto the user in all these rollup networks consist of the execution fees on the L2. These are typically determined by the gas auction and then the capacity of the blocks that is available currently in the spectrum of L2s. We actually see that there is an abundance of capacity in L2 blocks. Then they are determined by the amount of data and the form in which this data is being recorded on the data availability of that given rollup. So if we went by the true definition of a rollup should be recording the data directly onto L1 that it actually uses. So that's the second component. And then the third component that might or might not exist is some fee that is associated with the necessity to run some infrastructure for the given rollup. So the L2s that are zero knowledge, they might or might not project part of the proving onto the users, or they might choose to subsidize it, right? Because as networks operate, they might have other source of revenue, and that might be absolutely viable and doable for them. So that is going to play into your selection of whether you want to be on optimistic or zero knowledge, and what kind of transaction fees you are looking for your users. And then, as the last consideration comes all these special features, right, that you might want from your rollup. So if you require some special opcodes to be implemented in your EVM, then you will be looking for the rollup that is providing these opcodes. If you are developing a DeFi protocol, maybe you should be looking for a rollup that gives you something more in terms of security, in which case Zircuit could be a very, very good consideration. So it really depends what exactly you are doing.
You've recently launched your Build to Earn program. Does it help you to attract more developers?
Yes, so the Build to Earn program, it's actually an evolution of our previous staking program that it's still ongoing, right? So we have received tremendous traction in both. The staking program went live in March, and roughly within 3-4 weeks we have collected $1 billion in stakes. Now, when you look at it at this very moment, the amount of funds locked in that contract, it's exceeding $3 billion, right, and in dollar terms. So this is
Yeah,
great.
that's
This
great.
is
Great
this
result.
yeah.
Even before the main net launch.
Yes, this is a great result. But so when you look at these assets. What the users are essentially indicating in here is, yes, we are showing that we are willing to participate in the Zircuit ecosystem. So it's time to create the Zircuit ecosystem, right? So that the DeFi protocols and all the builders, they can benefit from the availability of these assets. So this is, why we launched Build to Earn and how we are segueing into supporting our developer community. And again, we have received a tremendous amount of traction. We have over 1,000 submissions in the Build to Earn program right now. They are greatly varied. Some of them are infrastructure partners. Some of them are protocols that are building on Zircuit and will be deploying upon the launch of mainnet. So everything is booming, and we are very proud and humbled by the reception of Zircuit by the community.
Yeah, that's great. Do you have ideas how to keep all of them? Because from what I see, when something new occurs in the market, a lot of users, a lot of liquidity, a lot of developers go there because they're hoping for airdrops or something, but then they go to the next roll up, to the next blockchain, whatever. So what are your ideas how to keep them?
So I will absolutely acknowledge this observation. I've had this observation myself, and I agree. This behavior pattern certainly exists, and yes, we do have ideas. We are very heavily discussing all of these ideas with the builders who are working on projects for Zircuit, and I will not mention any of them just because
Okay.
discussions are in progress. I don't want to promise anything. I don't want to advertise anything. If this is relevant to you, please join the Build to Earn program, and we will open this very same conversation with you and let you, take a look a little bit deeper under the hood in here. But I will not answer directly.
Okay. Couple of last questions. So I didn't find the information about the funding rounds. I don't. Okay. So your plan is to be funded from the community at first,
Our plan
mainly.
is to accept the angel investments to the extent that we actually need them, and whatever the network might bring will be heavily focused on the community of users and builders that are actually spending their effort on progressing the state of the network and the ecosystem on it.
Okay. Okay. And what are your thoughts on launching a token? So I'm sure you definitely will do this. But in general, so do you think every layer two really needs its own token, or do you think it's more like for someone it's more like everyone does it, so we will do it as well, or it's, I don't know, it's easier to explain to investors. So why do they need to invest? What are your thoughts here?
So I will not be commenting on the intentions of Zircuit with respect to launching a token. However, what we can see in the space is that other networks have launched tokens. Some of them have found ways of working in some creative way with tokens. So I can see how this can be an asset for L2 in the future. But as I said, I will not be commenting on intentions of Zircuit in this area.
Okay, fair enough. Yeah, but I couldn't resist talking about it a little bit. Okay, so yeah, I think that's mainly most of the questions I wanted to ask. Maybe there is something important about Circuit you just wanted to add, which I didn't ask, or maybe just some kind of a call to actions to our listeners.
Call to actions to the listeners. Well, we are trying to bring our best to Zircuit. We are, bringing all this expertise and exercising it while developing Zircuit. So we want Zircuit to be, the best and highly quality executed network. So as a call to action, if you like that, if you like the research that we are doing, if you like the concepts that we are bringing to the table, please come build on Zircuit. Give it a shot, try it. We have testnet out there. The testnet is greatly stable. If anything doesn't work, we want to hear about it as soon as we can. But an open invitation. Please try and work with us.
Perfect. I'm sure they do. I'm sure they will. Thank you, Martin. Thanks for coming. It was nice talking to you.
Thank you, Alex. Really appreciate it. Wish you a beautiful day.
See you at our events.